howdy there, partners. How you doing? Hey, Mr. War here. Yes, you got it. It's another fun-filled math video. Yes, yes, yes. Okay, I'm sorry. I'll try to calm down a little bit here. Let's go ahead and get started. This is the end of Module 3, Assessment Review. Yes, that means Eureka. Eureka is what we're doing here. And this should be a lot of fun. So let's go ahead and get started with my pen. Okie dokie. It says here, on Sunday, Niobe bought 6.5 kilograms of plant food. She does like to garden, huh? Anyway, she used 1 1/4 kilograms on her strawberry plants, and of course she used 1/8 kilogram for her tomato plants. Okay, nice. How many kilograms of plant food did Niobe have left? That's a great question. Write one or more equations to show how you reached your answer. All right, fair enough. Let me go ahead and just do a little switcheroo here. We'll bring out this little guy. He looks just like a normal, innocent-looking little black line, but he's going to turn into a tape diagram. I know you're thinking, Mr. Worrell, we love tape diagrams. So do I. I love tape diagrams. Let's go ahead and mark this baby up. Let me get another color. So here, first thing is we need to really make sure that we do the read, right? The RDW method. We're going to read the problem carefully, getting a good understanding. We're going to draw, which what we're getting ready to do here. And then, of course, write, because it's important to articulate our understanding. So basically, I'm understanding that we seem like we have this total amount of plant food. Okay? And then she is deciding to distribute some of the plant food on her strawberry plants, this much, and the rest of it she's going to put on her tomato plants here. Or not the rest of it. Actually, that's not true. She's not going to use all of it. She's going to use 1/8 kilogram. But I guess what I'm thinking in my mind is that, well, the first thing with my tape diagram, it really doesn't matter how large I make it. I'm seeing all of it together is going to be my 6.5. That's right, 6.5 kilograms. That's all of it together. That's all the plant food, probably in one bag. And then we would have to ask Niobe to get that answer, wouldn't we? I think we would. So how can I start to break up this tape diagram? Well, first of all, I look at this number 1/8, and I'm thinking this is a unit fraction. You know what? This baby is small. He's tiny, teeny, okay? He's not close to a half with our benchmark fraction that we use. It's really small. So I'm just going to go ahead and mark a really small little sliver just to show that 1/8, okay? This is just an estimate. And then I look over here and I see that she used 1 1/4 kilograms of plant food for her strawberry plants. Oh, it really doesn't matter. I'll make it a little bit larger. I'll just say that. It's just an estimate. I'm just marking my tape diagram. And what this does, my friends, is it helps me understand the problem better when I can visualize it, when I can draw it. And, you know, let's face it, I just like to draw, okay? I'm not very good at it, but I do like doing it. So we have the 1 1/4 kilograms of the plant food for the strawberry plants and the 1/8 for the tomato plants. So that basically means, well, this here is going to be what is left. So I'm going to put what's left. What is left? This is what's left, okay? Oh, here we go. So this is what's left here of the plant food. Okay, well, this is getting me to think now. If this amount and that amount was used from this bag here of this amount, it seems to me that my equation I could write from the get-go and would probably be, let me go ahead and get another little pen here. I'm going to get black. So I'm going to go ahead and say, well, if 6.5 is the total, I'm going to write that down. That's going to be equal to what's left, like in our box, right? And plus my 1 1/4 plus 1/8. Agree with that? All of that. We're trying to find out this quantity here. Now, I've written an equation like this to understand the whole problem. There's a total amount here, and so I'm just trying to get to that amount. So it seems to me that if I were to add these two quantities to whatever the empty box was, I would get here. Or, in other words, this problem also says then, I'm going to go ahead and add this. I'm going to have my variable, my empty box. And so then I could take the 6.5 and subtract that quantity here, and that would give me what's in the empty box. I mean, that may seem kind of confusing, but this is as simple as 7 is equal to 4 plus 3. Oh, and we could, well, let's make this actually exactly like that. Okay, let's scratch that up. Blah, get out of here. Okay, so we're going to instead, let's do 12, just because I want to choose a different number, is equal to 4 plus 5 plus that empty box. Now I put them in a different order, but it's still the same. If I were to add the 4 and 5 together, then I could take the 12 and subtract that amount, and it's going to get me here. This is the same thing. It just looks more confusing because we have fractions. Well, let me go ahead and do that. Well, I see a common denominator here, and that is an 8. So I'm going to go ahead and put an 8 down here. And I'm still going to be adding those. I'm just going to change this. So this here is going to be 1. And now suddenly I have 2 8s. And then over here I still have my 1/8. Now if I rewrite the fraction again, okay, now I'm still going to put my empty box here. That's my unknown. And at some point we're going to just start putting the word x. But we basically have here 1, and then it looks like 3 8s. All right, so we have 1 and 3 8. Now I simply have to subtract. I'll take that amount and subtract. So this is that second equation, more equations. So now I'm going to write a new equation. This is going to be 6.5 minus 1 and 3 8 is going to equal, and I'm just going to use x this time, all right, to replace the box, because x marks the spot. That's right. So if I were to find, again, a common denominator, I still have 8. So I'm going to go ahead and put 6. I'm going to choose my 8. Of course, 2 times 4 is 8. So I do the same above, 1 times 4. I'm going to subtract. Here I have 8. Looks good. And now, simply still going to be 3 8. Nothing changes. And now I have my 1 here. Now I go ahead and move on. Now, fortunately, this numerator is larger than that one, so there's no problem. So I basically take 6 minus 1, which is 5. And then I take 4 minus 3, which is, of course, 1. So I'm left with 5 1/8 kilograms. That is the amount that I actually have left. I know, isn't that wonderful? I love it when problems just work out so nicely like that. And so that means I need to go to the next page. Now the next problem that you're going to have here, and I have the same problem written up here because this is like, you know, Eureka. Eureka! They have where, you know, you do one problem and then you have part B, part C. So we are still going to need the same problem we had because part B says Niobe wants to feed her strawberry plants 3 more times. Okay, and her tomato plants 1 more time. All right, she will use the same amounts of plant food as before. Okay, so she'll be using this here. And, oh, normally that erases. Well, hopefully, I hope you didn't get confused. That actually is part of the code word there. Okay, it is. Even though I didn't use my magic pen, it is. So I just gave you a hint. Okay, so we have 1 1/4 kilograms used for the strawberry plants and 1/8 for the tomato. Now, she wants to feed, okay, 3 more times, 1 more time for the tomato plants. She will use the same amounts. Okay, how much plant food will she need? Okay, does she have enough left to do so? Remember, we started off with this quantity. Explain your answer using words, pictures, or numbers. Ooh, I love the word or. Or is a conjunction. And that really signifies that I don't actually have to use all of these. I get to choose or. So I could use words, I could use picture, or numbers. Well, I'm going to choose numbers because I like algorithms, and so I'm going to go ahead and use numbers. So the first thing we will need, though, we will need to know how much was left, and we determined that was 5 1/8. All right, so I'm just going to put over here left, because this is how much was left. It was 5 1/8 kilograms. So I just want to make sure I have that note. Now for the strawberry plants, she's going to feed them 3 more times. Well, strawberry plants was 1 1/4. Okay. Now we haven't really learned how to multiply fractions at this point, so we're just going to go ahead and just add. If she's going to feed them 3 more times, I'm going to write that 3 times. Makes sense. Okay? And let's go ahead and determine what that quantity is first. What's nice about this one is we have the same denominator. So we just add 1, 2, 3, like that. And then we have the numerators, 1/4 3 times. Well, that's going to be 3/4. My goodness, this is easy. I like this problem. And now for the tomato plants, we have even a smaller number, and it says that she's just going to feed that one more time. That's 1/8. So if it's just one more time, then it's just, that's right, 1/8. So what are we doing here? We're taking the 3 3/4 now, and we're going to add that to the 1/8 to know how much food she's going to be using. So I'm going to bring that 1/8 up here. Now I'm going to find myself a common denominator, which I did right there. And we'll change that fraction to 6/8. This doesn't change. I still have my 3. Now if I add that together, I get 3 7/8. So now, this is how much food I had left. I had 5 1/8 kilogram. So the question becomes, I'm just going to draw a line here, which number is larger? Because the question, does she have enough left to do so? Well, this is how much she had left. This is how much she's going to need to use to feed her tomato plants one more time and her strawberry plants 3 more times. And the question is, yes, she will have enough, because this is 5 1/8. That's a larger number. Okay, that's larger, so sure, yes, you're going to have enough. It says explain your answer using, okay, and we did that. I think we came through. Yes, yes, yes. Okay, and let me come up here, and I think it's time for that. So I kind of can't keep track in my mind. Okay, next problem. Ooh, Raul. Yes. Raul, my friend, it is your turn. You are the chosen one. Just kidding. Okay. So come on, Mr. War, let's get serious. This is math we're teaching here. It says Raul harvests the strawberries and tomatoes in his garden. Oh, what is it? Niobe and Raul have strawberries and tomatoes. Interesting. Okay. It says that he picks 2 1/9 kilograms less strawberries in the morning than in the afternoon. If Raul picked 3.5 kilograms in the morning, how many kilograms of strawberries does he pick in the afternoon? Explain your answer using words, pictures, or equations. Okay, now there's a lot of different ways we could do this. Again, we could use a tape diagram. There's other things. I'm going to go ahead and just use probably equations. And I know that this problem may seem really, really confusing, but let's just take it. You know what I say when this happens? I say, slow down. Okay, no need to rush. We'll just make sure that we understand it. It says that he picks this much less. So this isn't how much he picked in the morning, it's how much he picked less. Compared to what? Well, compared to the afternoon. So he picked this amount less than he did in the afternoon, which I'm going to make this statement. That means that he picked more strawberries in the afternoon. And I keep saying this different ways because that's going to help me understand, because we're doing the RDW, right? Read, draw, write. So if Raul picked 3.5 kilograms in the morning, okay, so now they're telling us exactly how many he picked in the morning. How many kilograms of strawberries did he pick in the afternoon? Well, if this is the morning, I'm just going to put M, okay? M's just going to equal 3.5 kilograms. That's what he picked. That's how much he picked in the morning. Well, but he picked less in the morning. That much less. Okay. Well, logic tells me then the afternoon's going to be my 3.5, right, plus the 2 1/9. Then that way we can find out how much he picked in the afternoon, because he did pick more. Really, 2 1/9 kilograms more. Or, if you will, 2 1/9 less strawberries in the morning than in the afternoon. Just switching the problem around. So let me see what that's going to be then, to see how much he actually picked in the afternoon. That's going to equal, we'll get ourselves a common denominator. I believe you all can see that 18 would be a good one. We're going to be adding. Okay, this is going to change that fraction to 9/18, where this one's going to be 2/18. We have a 3. Uh-oh. Ooh, we have a 2. Ooh, look how I fit that in there. Yes, Mr. War, you sometimes rock. Okay, and so then here we have 5, and then we have 11/18. Cool. So that's how much he picked in the afternoon. So is that it? That's the whole thing? Wow. That problem was easy. Easy peasy. Lemon squeezy. All right. Now, we're moving on. Again? Okay. It's another Raul problem. Okay, Raul. And you and your strawberries and tomatoes. Raul also picks tomatoes from his garden. Okay. Like Niobe did. It says he picked 5 and 7/10 kilograms, but, ooh, seems like there should be a little comma there, but 2.8 or 2 and 8/10 kilograms were rotten. No. And had to be thrown away. Oh dear, 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 dear. Okay. I understand. Maybe they weren't picked on time. I don't know. How many kilograms of tomatoes were not rotten? Ooh, trying to trick us. So they tell us how many are rotten. We need to find out how many are not rotten. And this is write an equation that shows how you reached your answer, which is what we've pretty much been doing at this point. Okay, so let's go ahead and take and do our RDW. Okay, reading it and understanding it. I have this amount, so this is, again, seems like some kind of total, because here it just says that's how much he picked. So if you can pick him, if you can picture, I think I can. Can you picture Raul in his garden? I think I can. Bent over, picking tomatoes one by one. And then at the end of the day, oh, my back is killing me. I picked 5 and 7/10 kilograms. Okay. However, while they were all in the basket, we know that 2.8 kilograms were rotten. So it seems like I'm going to subtract here to find out how many were good, because if they're rotten, we can't use them, unfortunately. However, they gave us this decimal. Now, for some, that might be a little bit confusing, but for some of us, it's no problem at all, because when we look at that, we say, no, you know what? That's a challenge. I'm going to go ahead and take that challenge. I'm going to change 2, because 2 is a whole, and anything to the right of the decimal I know is less than 1. That's going to be my fraction part. Well, if he's in the 10th place, I seem like I can put a 10, and I just put an 8 up there. My goodness, was that easy. Now I'm going to go ahead and subtract. Oh my goodness, and they have the same denominator. How nice is that? Oh, big problem though. 7 minus 8, we can't do that. How many of you try to do this? Oh, I'm just going to go the other way. Oh, we can't do that. You can't take 8 from 7. You just can't. All right, so we're going to go ahead and have to rename this whole number here. And it's like a way of regrouping. I'm going to go ahead and get another color so you can see this all happen in blue. Okay, so I'm going to take one of those holes away. That's only going to leave 4. One hole. One hole means that I need to try to get that hole over to him, because the numerator is the one that needs the help. So if I take one hole, we know that one hole is 1 over 1. It's 2 over 2. It's actually any numerator over the denominator that has the same number. Okay? These are all because 3 divided by 3 is 1, 2 divided by 2 is 1. Well, in this case, since we have that denominator of 10, let's go ahead and loan him 10 over 10. And we're going to squeeze that over there and bring it on. And that's going to make 10 plus the 7 that's already there, 17. Boy, do I love math. So then I'm going to go ahead and say 17 minus 8 is equal to 9. Last time I checked. And then the denominator, we just bring it over. Okay, I like doing that. So that's 9/10. Now we have 4 that was left here, minus the 2, which is 2. Can I squeeze them in? Yeah, I can. So 2 and 9/10. So I would say that 2 and 9/10 are how many kilograms of tomatoes that were not rotten. Okay? So based on that, yeah, a lot of them were rotten. My goodness. Looking at that number, that's about half. About half of them were all rotten. Sorry, Raul. That's how it goes sometimes, okay? And I'll just put over here, were not rotten, okay? All right, moving on. Looks like we're on the last page. Yes. Oh, another Raul problem. More, that's 3 times. It just keeps continuing. After throwing away the rotten tomatoes, probably a good thing that he did that. This is, did Raul get more kilograms of strawberries or tomatoes? How many more kilograms? Again, explains your answer using an equation. All right, well, we're going to have to sneak back to this page here, because what we need to do is, of course, the RDW. Am I still a magic pen? I think I might be. Nope, I'm not. Okay, so it says here that, so we're going to throw out the rotten, so we're not counting those. We have to compare the kilograms of strawberries to tomatoes. Well, we need to know what those the ones were that he was picked. That was like the first problem here. Here showed how many strawberries, correct? Yeah, this was the strawberry day he was picking. And that he actually picked, it looks like, oh, 5 and 11/18 in the afternoon. Interesting. So that's how many he picked in the afternoon. This is how many he picked in the morning. So, and yeah, so what we need to do here is make sure it's not talking, it's talking about all, right? More, yeah, it doesn't say. So it's going to be all the strawberries. So we actually have to do some math here. We have to first figure out what is 5 and 11/18 because that's how many he picked in the afternoon. And then he picked 3.5 in the morning. Okay, now again, you can see the common denominator, 18. So I'm going to put 5, put my 18. And of course, that's going to stay 11 plus 3. That's going to be 18. And then that's going to be 9. Now I'm going to end up with 8, and it looks like 20 over 18. Sorry, I'm going to have to go way over here. Woo! Yeah. Yes, that was fun. And then look, I have another whole here, 18 over 18. So I have 8 plus 18 over 18. And that would only leave 2 over 18 left. There's your 20. So that's going to equal 9 2/18. Or I would write this as 9 1/9 because I reduced. Okay, so that's the number I need for strawberries. Okay, let's jet back to page 5. Ooh, not 6. All right, so we have, that was 9, I believe, and 1/9. Okay, that's for strawberries. And then tomatoes, do we determine how many? Well, we have to go back to this page for tomatoes. It says here that 2 9/10 were not rotten. Well, we don't want the rotten ones because it said after throwing away the rotten ones. Oh my goodness. So if it was only 2 and, what did I say, 9/10? 2 and 9/10? Yes. 2 and 9/10. So that lets me know right there that, oh my goodness, yeah, he definitely picked more strawberries. Because 9 1/9 kilograms is much more than 2 and 9/10. And, okay, so how many more kilograms? Okay. Oh, they want to know, okay, and we have to also answer how many more kilograms. All right, one more step. 9, and now we have to subtract 2 and 9/10. All right, we look at this. Common denominator, 90, probably the easiest one. Okay, times 10 makes that 10/90. Over here, that's going to be times 9. Oh, let me get my 90 down there. Times 9 equals 81. Okay, because 10 times 9, you get that, 90, okay? And then, oh my goodness, the 10 and the 81, that's a problem. So I need to regroup. I'm going to go ahead and make 90 90ths. I'm going to go ahead, add that on to my 10. Now I have 100. Isn't that nice? All right, he turns to an 8. Now we have 100 minus 81. Well, it would be 20 minus 1. I got 19. So 19 over 90, and then we have our 8 minus 2, which is 6. So I say 6 19/90ths. Now, I did this kind of quickly. I may have made a mistake. You're more than welcome to challenge my answer. And I believe that pretty much covers it. In the right part here, I would be writing that Raul picked more strawberry, or that Raul ended up with a harvest of more strawberries than tomatoes, and he actually has 6 and 19/90ths. And this is a prime number, so this won't get any smaller. Okay, so pretty much I think that covers it. Now what you need to make sure is, of course, you do that special little thing that gets you credit, and I think that covers it. My friends, as always, live long and prosper.